Hello, so today we're going to go through a paper 2 for the Cambridge syllabus. And yeah, if you don't already know me, I am a fully fledged chemistry teacher with over 10 years experience, so hopefully I can offer you some exciting tips and tricks as we move through today. So let's just get started. So question number 1. So which gases will diffuse at the same rate at the same temperature? So this question is asking us basically which gases are the same mass, have the same molecular mass. So we can look through them nice and quickly. So it can't be these two because we've got an extra carbon dioxide. It probably is these, as if we look at the periodic table, yeah, these would have the same molecular mass. Can't be these and can't be these. So yeah, so it has to be B. Okay, so number 2, a student measures the time taken for 2 grams of magnesium to dissolve in 50 centimeters cubed of dilute sulfuric acid. Which apparatus is essential to complete this experiment? So we are looking at time and we are measuring out a volume. So we are going to need a stop clock, need a measuring cylinder, and we also need a balance because we're measuring out 2 grams. So hopefully we have 1, 2, 4, 1, 2, 4. There we go. Happy days. All right, so now we have some protons and neutrons and some electronic structures for some elements. There we go. Our question is, so which particles have the same chemical properties? So chemical properties are always kind of dictated with the electronic structure, and yet if we have an ion formed or not. So let's have a look at our electronic structure. So these 3 are, what am I doing? Yep. So these are the same, and these are the same. So now let's have a look at if the number of protons matches up. So here we go, these protons match up. These are different, so we should be, let's use the same colour. So it should be these two, X and Y. Here we go, X and Y, happy days. Okay, which substance should be pure for their intended use? Wow. We definitely want pure drugs because impurities can cause damage to humans, but let's just check out the others. Limestone for the extraction of iron, doesn't really matter. Petroleum for fractional distillation. Well, fractional distillation is like the kind of not purification, but it's like part of the refinement of it. So not that. And then water for washing cars. Well, I don't know about you, but when I wash my car, it's certainly not done with pure water. As yet, in chemistry terms, pure just means one substance. So water from the tap has got lots of other things in it. So yeah, clean water is different to pure water. So yeah, so our answer has to be A. Okay, metals and ionic compounds have similarities and differences in their structure and properties. Which row about metals and ionic compounds is correct? Well, let's have a look at each one. So similarities. Both contain positive ions. So yeah, we're looking at metals and ionic compounds. So both contain positive ions, so that's true. Difference, only ionic compounds contain anions. So that's true. This is true. Ionic compounds have a delocalized electrons. No. Both are malleable. No and no. So there we go. So our answer has to be A. We don't even need to look at reading the rest. Okay, so yeah, even if the first answer is the correct one, is the first one you look at, it's always good just to eliminate the other answers just to make sure. Okay, which diagram represents the outer shell electron arrangement for a nitrogen molecule? Okay, so it is the dot cross diagram. If we can remember the dot cross diagrams, we need to have 8 electrons in our outer shell. So when you kind of go round each atom, you should be able to count up to 8. So if we go here, that is only 6, so it can't be that. Here we've got 1, 2, 3, 4, 5, 6. So yeah, can't be that. We've got 1, 2, 3, 4, 5, 6, 7. Can't be this one. So here you've got 1, 2, 3, 4, 5, 6, 7, 8. So yeah, it can only be D. There we go. Okay, the equation for the reaction between barium chloride and dilute sulfuric acid is shown here. State symbols. What is the correct state symbols for this reaction? So let us have a little think. So before we look at the correct rows, we could just be thinking about the things that are solid or liquid or aqueous. Where's the pen? Here's the pen. So barium chloride, yeah, is aqueous. Sulfuric acid is an acid, so that is always aqueous. This is, I guess, testing analogy if we can remember that barium sulfate, yeah, forms a precipitate, and precipitates are solid. So this one has to be solid, and yeah, hydrochloric acid is of course aqueous. So which matches up to AQ, AQ, SAQ? Okay, AQ, AQ, SAQ. So here we go. So it has to be A. Okay, the relative atomic mass of an element is determined by comparing the mass of one atom of an element with the mass of one atom of element Q. Which one is it? Well, they're all compared to carbon. So this is just something you need to know. So yeah, so everything is compared to carbon-12. And yeah, everything, yeah, all of the atomic masses, yeah, are just compared to carbon-12. So that's just something you need to know. So yeah, it is to do with the definition of relative atomic mass. So yeah, you might have been asked this in the paper before, like how to, yeah, what is everything compared to? Then you have to write it down. Or we have it here as a multiple choice question. So yeah, so remembering it is carbon, or more specifically carbon-12. Okay, the equation for the reaction between aqueous lead, aqueous sodium chloride is shown here. We've got this much aqueous lead nitrite of a concentration of this is reacted with an excess of aqueous sodium chloride. Okay, how much aqueous, what is the mass of the lead 2 chloride that is obtained? So we are looking at this and this. Okay, so first of all, so we're not going to look at the answer straight away. We can see we've got a 1:1 ratio. So once we've figured out the moles, then once we know the moles, we can figure out the mass. So we've got our solution. So moles is concentration times the volume. So what is our concentration? 0.1, and our volume is 0.1. So that is 0.01. Just have to find a calculator to double check that. So now we know the moles. That's going to be the same as the moles of lead chloride getting formed. So then we need to get the mass. So mass is going to be moles times mR. Quite a lot going on in this question. So let me just secretly use my calculator again. Okay, so there we go. Once we've used our calculator, we've got we can get to our answer. Here we go. So quite a lot going on to give us our answer in C. For 9, which is C. Okay, let's hope the next one is a bit more forgiving. Okay, so we've got some electrolysis. We have hydrochloric acid, sodium chloride, carbon electrodes. Okay, acid, sodium chloride, at which electrodes is hydrogen produced? Well, let's have a think about what's going on before we look at our answers. So in this electrolysis, we do have hydrogen because it is a solution. This is also a solution, so all solutions contain the hydrogen ion. So we then need to think, where is the hydrogen ion going? So it is the cation goes to the cathode, so that is the negative electrode. So our negative electrode, so electrode 2 and electrode 4. So let's have a look at our answers. So yeah, 2 and 4, there we go, happy days. Okay, copper 2 sulfate is electrolyzed using copper electrodes, so that is important. We have copper electrodes, copper sulfate. What is the ionic half equation for the reaction at the cathode? So the cathode is, yeah, the cation. So in our electrolysis experiment, our cations are copper 2+ and the hydrogen ion, but because they're copper electrodes, they're taking part in the reaction. So the copper isn't forming, sorry, the hydrogen isn't forming in this case, but the copper is. And yeah, the copper is gaining 2 electrons. So yeah, there we go. It has to be this half equation here. Okay, which row identifies the chemical change and a physical change? So chemical change, physical change. So let's start with eliminating some straight away. So boiling is not chemical, dissolving is not chemical. So it can't be these. Or evaporating is also not chemical, so let's check if this is correct. So this is correct, so this one has to be correct, and it is. So yeah, so our answer is B. So with these, I would maybe just look at one column first, because it makes things a bit easier and a bit simpler for you. Okay, more reading. So we've got an equation between hydrogen, iodine, to give us hydrogen iodide. Oh yeah, here it is. It is exothermic. So which statement explains why the reaction is exothermic? So that's the only important part. We don't really care about what's reacting. So the energy released when the HH and HI bonds are broken, energy is released. Well, this is not true. Bond breaking is always endothermic. And even that wouldn't answer the question. The bond energies in the reactants are larger than the bond energies in the products. I don't think that's true. The products are at a higher energy than the reactants. That one can't be true. So more energy is released when 2 HI bonds are formed than it's used to break those bonds. Yes, it has to be D. That's the only one that is correct. Okay, so first of all, what is the silver nitrate doing? So yeah, that is the test for the chloride ions, and we need to know that color change. So it is white, so it has to be either C or D. Then what happens when you leave it in sunlight? Well, the precipitate does not dissolve, it turns grey. So we don't even need to look at what is going on with the explanation. But yeah, this is also correct. The silver ions are reduced. So yeah, our answer has to be D. Right, water is added to anhydrous copper 2 sulfate. What is happening? So, well, it is going to turn blue. And what else is going to happen? Well, it is going to get hotter. It's a very exothermic reaction, actually. Nice and toasty. So what is that? So it can't be this one or this one. Turning blue, and it's going to get hotter. Yes, so it has to be B. Okay, now on to number 16. So let's see what is going on here. So we've got a reaction that needs balancing by the looks of it. Figuring out something as an oxidizing agent. And are we getting a dark brown solution being produced? Well, that's the easiest thing to figure out first, as we are getting iodine formed, so we are going to get a dark brown solution. I think the other two need a little bit more thought. So let's see with balancing the equation. So first things first, as we have 2 iodines, then we need to balance this with a 2. Now we need to balance the potassium. So if we put a 2 over here. Now let's have a look at the chlorine. So now we've got 4 chlorines and only 3 over here. So that doesn't work. So if we put 2 here, now I need to balance the iron. And now let's check if the chlorine's balanced. So we've got 6 and then 4, 5, 6. So there we go, happy days. So in the balanced equation, they do all have the same value. So now let's have a look at potassium iodide being the oxidizing agent. So what is going on? So potassium oxide, so this is starting off as, well, the iodine, starting off as -1, and it's ending up as an element, so it's going to a 0. So it has, in fact, lost electrons. So it's not the oxidizing agent, so this one is not true. So we've got 1 and 3. So 1 and 3. So yeah, our answer has to be B. So this is one of the trickier questions so far. Okay, let's hope our next one is a bit easier. Okay, let's look at number 17. So which statement about acids is correct? A strong acid has a higher pH than a weak acid. That is not true. It's going to have a lower pH. An acid is a proton acceptor. Well, acids are not proton acceptors. They are proton donors, so it doesn't matter if it's a weak or strong acid. All acids are proton donors. And a weak acid is fully ionized. No, it is not. That is a strong acid, so yeah, it has to be C. Okay, the two oxides of two elements, X and Y, are separately dissolved in water, and the pH of each solution is tested. Okay, very nice. Which information about X and Y is correct? Well, we can have a look at what we've got here. So, and these pHs, so this is probably an acid, this is probably an alkali. Oh, and they're both oxides. There we go. Let's have you read the question. So which information about X and Y is correct? So oxide is acidic. So X is an acidic oxide. So it is this, so it can't be C or D. Oxide Y is basic. Yeah, well, that checks out. Now we need to see which are the acidic oxides, what are the basic oxides. So basic oxides are metal oxides. So our metal oxide has to be the base, so that has to be Y. And then our non-metal, yeah, are acidic oxides. So there we go. So it has to be B. Right, an acid is neutralized by adding an excess of insoluble solid base. A soluble salt is formed. All right. So how is the pure salt obtained from the reaction mixture? So, so it's a soluble salt. So we can't do this or this, so it can't be filtration. Is it going to be evaporation or crystallization? Well, the first thing you need to do is, yeah, a bit of evaporation to get it to a crystallization point, and then once it's crystallized, then you can filter your mixture. So there we go. The electronic structure of element Z is this. What is true about this? Well, it is in group 1, so it has to be, it is a metal. It has 2 outer shell electrons, no way. And it's in period 3. Well, we've got 1, 2, 3. So yeah, it is in period 3. So 1 and 3. There we go. Happy days. Halfway through. Okay, elements in group 4 of the periodic table are shown. Yeah, there they are. What does not occur in group 4 as it descends? So as we go down the group. So we are looking for a not. So this is true. This is true. This is not true. And this is true. You get more shells here as you go down that group. So it has to be C. Okay, element M forms both M plus and M2 plus. Which part of the periodic table is it in? Well, if it has a variable oxidation state, the only answer is, yeah, the transition elements. Okay, in the extraction of aluminium by electrolysis, cryolite is added to the bauxite ore. Which row describes the role of cryolite and gives the half equation for the cathode? Well, it is lowering the temperature of the cryolite, so it has to be either, yeah, C or D. And what's going on at the cathode? Well, that doesn't make any sense at all. How can that become that? So it has to be this. There we go. Okay, mild steel is galvanized to prevent corrosion of the iron. Of course it is. Which statement about galvanizing is correct? So it is galvanizing, means covering it in zinc. So if we can remember that, let's see what these statements are. So galvanizing prevents corrosion because the zinc forms an alloy. An alloy. It's not an alloy, it's a protective layer. If the coating is damaged, water and oxygen do not corrode the iron. That is true. Zinc is a sacrificial metal. It is a sacrificial metal. So there we go. It has to be this. So yeah, so the zinc corrodes instead of the iron. Okay, which diagram represents the arrangement of the outer shell electrons of a noble gas? Well, we have to have a full outer shell. So if we look at here, we've got a full outer shell. So already, it's probably going to be A. Let's just check the others. This is not full. This is not full. And this is not full. So yeah, so the first shell only needs 2 electrons to be full. So yeah, there we go. That's why our answer is A. Which statement about the general properties of metals are correct? So let's just read through them one by one. So they are good conductors. Oh, let's get the pen. They have high melting and boiling points. They do react with acids, but they do not form water. They form hydrogen. Remember that equation? And they react with oxygen to form basic oxides. They do. We've already looked at that today. So it is 1 and 4. There we go. All right, reactions of 3 metals and their oxides are shown. Okay, nice, nice, nice. Dilute. What is the order of reactivity of these metals? Okay, so let's have a quick look at what's going on. So reacting with acid, we've got a no. So 3 is definitely at the bottom. So from most reactive to least reactive. So we want this to be over here. So it's either A or C. Can't tell any other information from that column. Heat the metal oxide with carbon. So the carbon is used to displace the oxygen. And if it can't, that means that metal is more reactive than carbon. So here we go. So number 2 is our most reactive. And here we go. That checks out. We've got a 2 over here. So our answer has to be C. Okay, so on to 28. So we've got our 3 compounds heated using a Bunsen burner. And we've got some results. So what can we figure out from the results? So let's go through each one. Yeah, need to go through each one at a time. So starting off with J, so we're getting a colourless gas produced, which relights a glowing splint. So that gas is oxygen. So out of these, which is going to give us oxygen? Well, it's not going to be these. So it has to be either these. Okay, so we're already down to C or D. Now on to K. So this time we're getting another colourless gas, which is turning lime water milky. Well, that has to be carbon dioxide. And what can give us carbon dioxide? Well, that has to be a carbonate. Which, yeah, well, is either this or this. But as we'll see from our next one, from L, gives us no reaction. And yeah, that is potassium carbonate. That's because it's very stable and that does not react when you heat it up. So there we go. Our answer, yeah, has to be C. Okay, we've got a diagram to show the treatment of water, the treatment process of muddy river water. Okay. Which row identifies uses 1 and 2 and processes 1 and 2? So let's have a look at uses. So muddy river water, use 1, drinking. It's not going to be drinking. Watering crops. Disinfected water, drinking. Okay, makes sense. Process 1, muddy to clean river water. Well, that has to be filtration. Process 2, disinfected water, yeah, is chlorination. So our answer has to be D. Okay, question 30. So it's to do with the Haber process by the looks of it, and yeah, the making of ammonia. So yeah, we've got the equation there. It's telling us it is exothermic, so we can put that in, exothermic. And then yeah, how is each change going to affect, first of all, the rate of reaction and then the yield? So we'll look at the rate of reaction first. So decreasing pressure, well, that is wrong, because yeah, that's not going to increase. If you decrease the temperature, the rate of reaction is going to decrease. If you increase the pressure, the rate is going to increase. And if you increase the temperature, yeah, the rate of reaction is going to increase. Okay, so we've got rid of one answer there. All right, so if we decrease the temperature, yes, this is going to increase the yield because it's going to shift the reaction to the exothermic side. Let's just double check our other ones are not right. So it's probably going to be B. So if we increase the pressure, yes, this does decrease the yield, and then increasing the temperature, yeah, well, we already know that's not going to increase the yield, so yeah, our answer has to be B. Okay, fertilizers are used to provide 3 elements needed for plant growth. Which 2 compounds would give a fertilizer containing all 3 of those elements? Well, let's remember what those elements are. N, P, K. So NPK fertilizers, or NPK numbers. So this is what you need for a fertilizer. You need nitrogen, phosphorus, and potassium. So what contains all of them? Well, we've got no phosphorus here. We've got phosphorus, nitrogen, but none of that. We've got that, that. So hopefully it's the last one. Yes, yes, yes. Okay, happy days. It's D. Okay, we've got the process of sulfuric acid and its electrolysis. Okay, very good. What are gases 1, 2, and 3? Well, gas 1 has to be sulfur dioxide, because sulfur dioxide is reactive with oxygen to give you the sulfur trioxide. So it has to be at A or B. And then yeah, sulfur trioxide. And then we are left with what is gas 2. Well, we've already spoken about it. It is oxygen. So there we go. We have to have, yeah, the answer has to be B. Okay, on to number 33. So let's go through, yes, we've got our statement here. So let's go through them one by one. So sulfur dioxide decolorizes acidified potassium permanganate. It does. Sulfur dioxide forms when acids react with carbonates. Nope. Sulfur dioxide is used as a bleach. It can be, yes, because it's used to make sulfuric acid, which is in bleach. And then sulfur dioxide is used to treat acidic soil. No way. Okay, so there we go, it has to be A. Okay, what are the products when limestone is strongly heated, or heated strongly? Well, it is going to give us calcium oxide and carbon dioxide. So what do we have? So it can't be this or this. Has to be, yeah, has to be C. Okay, here we go. We've got an ester, very nice. Which row gives us the name of the ester and the carboxylic acid and the alcohol which made it? So looking at the ester, and if we look at our middle bit here, so this is going to give us all the clues to tell us what's going on. So here, this is the alcohol part. So from the single bonded oxygen gives us the alcohol. So then, yeah, all of this is coming from the carboxylic acid. And what do we have? So the alcohol has to be methanol because it's got 1 carbon. The carboxylic acid has 2. So there we go, those are both the same. And now remembering our name, well, it's always the alcohol part first. So it is, yeah, methyl ethanoate. All right, On to 36. So ethanol is made industrially by the fermentation of glucose or by the catalytic addition of steam to ethene. Which statement describes an advantage of fermentation compared to the catalytic addition? So ethanol is the only product of fermentation, so that is not true. So that's the advantage if you do the catalytic addition. So fermentation uses the batch process. That's continuous. That's not true. That's not true. And this is true. It does use a renewable source as you can keep growing your crop, so it has to be D. Okay, we've got some properties of a colourless liquid L. What do we want to do? So let's have a look at our answers first. So it's a very rare time we're looking at the answers, could help us out. So what is L? Is it ethanol? Is it hexane? Is it hexene? Is it ethanoic acid? All right. So if it boils, I don't know how helpful that one is. We can ignore that. When added to water, it forms two layers which do not mix. So this is very handy. So this means it is an inorganic. Sorry, it means it isn't. It means this is organic. So it's not going to be ethanol. It's not going to be ethanoic acid because they will dissolve in water. It does not react with sodium carbonate. Okay, that's not telling us anything. And then it has no effect on bromine water, so this is useful. So there we go, hexene. Hexene does affect bromine water, so our answer is hexane. Okay, there we go. All right, a molecule of compound P contains 2 carbon atoms and 4 hydrogen atoms. Which row represents P? 2 carbon and 4 hydrogen. So C2H4. So from this we need to be thinking about looking at this and figuring out what it has to be. So it can only be ethene, so there we go, so we're getting rid of A. Our molecular formula, so we've got 12, so that's 24 plus 4, so it's 28, so it has to be this. And yeah, it does react with bromine, so there we go, has to be C. Okay, we have our reaction here, so we've got ethanol reacting with acidified potassium permanganate. So we're going from ethanol to a carboxylic acid. Well, yeah, I guess this is just something you need to know. So this is an oxidation reaction, and we are using an oxidizing agent. And our final reaction, which polymer is a synthetic polyamide? Well, it is nylon, but it's not this, because this is not a polyamide. This is a natural polyamide, and this is just another example of an addition polymerization. So yeah, it has to be nylon. All right, so quite a long one there. So thank you for watching all the way to the end. I hope you found some useful things in the video, and yeah, please do remember to like and subscribe, and to tell all of your chemistry friends if you have enjoyed the video. All right, I will catch you in the next one. Bye.